Today we're going to start talking about derivatives, which are the most fundamental of topics in calculus. You've already done derivatives, you've just called them by a different name. So we're going to start by the slope at a point on a curve, which is the tangent line, is known as, that's supposed to say m. M is equal to the limit as h approaches 0 of the f of a plus h minus the f of a all over h. So you were doing this in the last section, no problemo. Now what we're going to say is that a derivative, denoted as f prime of x, you should look at page 101. There are numerous notations for a for a derivative. Generally, we use f prime of x frequently. We also use something called dy dx of the f of x. And that's the derivative of y with respect to x. So these are two very common notations. And again, you should look at page 101 to get a feel for what those all are. So the derivative, the f prime of x, is equal to the limit, you've done this, as h approaches 0 of the f of x plus h minus the f of x all over h. Look familiar? So now it has a more specific name, and it is called a derivative. Little side note, we talked about continuity and the right-hand limit equals the left-hand limit equals the exact value, and that's continuity. Well, derivatives don't exist everywhere, and that is because not all functions are continuous. So we say that the limit exists if the limit as you approach some value a from the left of a function is equal to the limit as x approaches a from the right of the function. And this is where we say the derivative exists, also known as differentiable. You can find the slope of the tangent line as long as this is true. Okay, you can find the slope of a tangent line at a specific point, obviously. This is what happens if I'm just going to find it at some general value of x. But what if I know x? What if I tell you x is 3 or x is 16? So at a specific point, and believe me, this is going to be super helpful. F prime of a is equal to the limit as x approaches a. So now we're talking about a specific point. In the general definition of a derivative, the slope of the tangent line, we're talking about generic h approaching 0. Now we're going to talk about a specific point a. And you are 100% for sure going to recognize that. So it's slope. It keeps saying over and over again, the slope of the tangent line, the slope of a tangent line. You have been doing this, I promise. So I'm going to look at number 4. There were some requests that I do specific examples from the book because that would help you with the homework. So I'm going to look at number 4. And number 4 is going to be about finding the derivative of a function at a given value. So they are giving me a specific value of a. I am going to show you 2 ways to do this. And I'm not sure pink shows up, so I'm going to go to blue, which I think is an easier color for you guys. Okay, so you are given that the f of x is equal to x cubed plus x. And I want to do that at a is 0. Okay, so we want to find the given, the derivative of the given value. Now, you'll notice that the directions say they want you to use the formula, the definition. The f of a, which is 0, plus h, minus the f of 0 all over h. Okay, so let's just plug in. This is going to be the f prime of a, which is equal to the limit, and yes, you need to write the limit the whole way down when you do the problem. So the f of h is h cubed plus h. The f of 0 is 0 all over h. This h in the denominator must reduce out. If it doesn't reduce out, then there's a problem. So this is going to be the f prime of a is equal to the limit as h approaches 0 of h squared plus 1, which I believe is 1. Sound good? So even though the directions don't say that you should use it at a specific point, I do want to show you what this looks like because in the big picture it's going to be a lot shorter. So I want to do now, and I'm just going to rewrite the definition. For me personally, I make a lot less mistakes if I write the whole thing out first. You do not have to. Okay, so the f of x is x cubed. Hold on, I forgot my prime notation. So this is the f prime of a is equal to the limit as x approaches 0. Here they asked me to use 0. I'm doing the same problem in two different ways. The f of x is x cubed plus x. The f of a is 0 all over x minus a, which is, x. See this? H cubed plus h over h, x cubed plus x over x. So this is equal to the limit as x approaches 0 of x squared plus 1, which is indeed 1. So why did I show you that? Because I want you to see that when you use the definition of the derivative, but then you use the slope at a specific point, you get the same answer. Okay, let's look at number 20. 20 is going to take you some space on your paper, so I recommend leaving yourself a fair amount of room. So number 18 says find the derivative of the function y equals, where am I at here? 2x squared minus 13x plus 5. And they want you to use that to find the equation of a line tangent to the curve at x equals 3. Okay, so I'm going to, the directions don't say which way I have to do it. And I will tell you that using the full-on definition, the f of x plus h minus the f of x over h for this one is actually pretty complex. So I'm going to use the f of x minus f of a over x minus a notation. Which one can you use? You know, it doesn't really specifically tell you which one. So I'm going to go for the shortcut. You should know how to do both. You should know how to do both. So this is the limit as x approaches 3 of the f of x minus the f of a, which in this case is 3, all over x minus a, which is 3. Okay, I can see why this is confusing to you. You're probably wondering, wait, Miss Babby, x is 3. A, x, it doesn't matter. So I'm going to change this to a. makes plugging into the formula probably less confusing for you. So here we go. F prime of x is equal to the limit as x approaches 3. The f of x is 2x squared minus 13x plus 5. The f of 3, I believe, is negative 16. So this becomes plus 16, I'm pretty sure. And this is over x minus 3. The x minus 3 has to reduce out. It must, because if you plug in 3, you get 0, and that's not going to help me. So here's where you have to remember your Algebra 1 factoring skills. So this is 2x squared minus 13x plus 21 over x minus 3. So this is where you cheat legally. I call it legally cheating. This x minus 3 must reduce out. You cannot plug in 3. If you plug in 3, you get an undefined value, and that's not going to happen, or it's not allowed. So this is what I do. I kind of factor backwards, especially if you are factoring challenged. X minus 3 had better be a part of the numerator, because then I can reduce the x minus 3's. So then working backwards, you get 2x minus 7, negative 1. You have not answered the question. This is the slope of the tangent line at 3, negative 16. This is the slope of the tangent line at 3, negative 16. It's not the tangent line, it's just the slope of the tangent line. So they want you to find the equation. Okay, so it's 316. So y minus 16 equals negative x minus 3. So this is y equals negative x plus 3 plus 19. That's not what it's supposed to be. I'm looking at my notes. It's supposed to be y. This is a negative. I made a mistake. That's supposed to be negative. This should be positive. So you get negative x minus 13. Sorry, I dropped a negative sign. And there's a future problem where you're asked to find the equation of the line normal. So normal is perpendicular. So they want to know the equation of a line, of the normal line to the tangent. So normal is perpendicular. Perpendicular, opposite reciprocal. The opposite reciprocal of negative 1 is 1. So you would have y plus 16 equals 1 times the quantity x minus 3. So y is equal to x minus 19. Okay, there's one more problem that I want to do, and that is number 20. And number 20 involves some bass-ackwards mathematics. So you're going to want to pay attention to number 20. It's got some funky math to it. If I were giving you a quiz or a test in class, I would be quizzing you on something like number 20. Okay, so number 20 says, find lines that are tangent and normal to the curve at root x, x equals 4. Okay. I'm sorry, what is it? Root x, x equals 4. Okay, so, sorry, I have all kinds of papers all over my table that you can't see that I'm trying to organize. All right, here we go. I'm going to do the problem both using the definition at a specific point, f of x minus f of a over x minus a, and I'm also going to do the problem using the full definition and each one presents its unique problems. I'm going to start with the definition of the derivative, which is the limit as h approaches 0 of the f of x plus h minus the f of x all over h. Again, I write it out for myself because then I'm going to make a lot less mistakes. So this becomes f prime of x is equal to the limit as h approaches 0 of the f of 4 plus h minus the f of 4 all over h. Hit pause, do it on your own, see if you're getting the same answers. You're going to get stuck at a certain point, I would imagine. So this becomes the f prime of x is equal to the limit as h approaches 0 of the square root of 4 plus h minus 2 all over h. And here's where the problem comes in. You can't just plug in h. Plug in h, you get 0 in the denominator. 0 in the denominator is undefined. There is something wrong. Okay, so normally we multiply by the conjugate. Well, I am going to multiply by the conjugate. The difference is I'm going to use the conjugate of the numerator, not the conjugate of the denominator. So this becomes, I'm going to multiply by root 4 plus h plus 2 over root 4 plus h plus 2. Can you do that? Absolutely. This is just a fancy form of 1. Absolutely, you can multiply by root 4 plus h plus 2 over root 4 plus h plus 2. Try saying that 10 times fast. Root 4 plus h plus 2, root 4 plus h plus 2, root 4... You know I couldn't resist. I just want to make sure you're paying attention because I can't see you. Gosh only knows what you're doing. Okay, so when you FOIL this, you get 4 plus h minus 4. So now you just threw a root in the denominator. You're right, I did throw a root in the denominator, but it's not going to be there forever. So this is going to end up being h root 4 plus h plus 2h. And you know what? I shouldn't have distributed. Oh well, it'll all work out in the long run. So you get f prime of x is equal to the limit as h approaches 0, h over, I'm going to undistribute, h root 4 plus h plus 2. See ya. This is equal to 1/4. This is a 1. 4 plus 0 is 4. Root 4 is 2 plus 2 is 4. This is the slope of the tangent when x is 4. This is a specific point though. This is a specific point x equals 4. So can you use the definition of the limit at a specific point? Absolutely. Well, then why did you do this whole thing? This is why. Because you need to understand that you can multiply by the conjugate even if it's multiplying by the conjugate of the numerator. Still okay. So the other way you can do this is you can say the limit as x approaches a of the f of x minus the f of a all over x minus a. And I forgot f prime. So here's where you have to be careful. Your x is 4 now becomes a is 4. Don't let the variables mess you up. So my specific value of a is 4. All right, here we go. And I am going to continue to forget my derivative notation. Derivative, it is the specific name for the slope of a curve at a specific point. The f of x is root x. The f of a, root 4 is 2. All over x minus 2. Guess what? Same issue. Same issue. If you plug, oh, this should not say a. Let's go back. This should say 2. This should say 2. I know A is 2. If I plug in 2, I get 0, so I'm going to multiply by root x plus 2 over root x plus 2. All right, so this is the limit as x approaches 2 with the derivative notation. This is x minus 4 over, is that right? Yeah, that's x minus 4 over x minus 2 root x, x minus 4, x minus, I made a mistake here. This is x minus 2. I'm sorry, I made a mistake. I'm trying to figure out what I did wrong. Because A is 4. My apologies. A is 4. So this should be x minus 2. That's right, but this should be x minus 4. I knew I made a mistake because I got to this point and nothing reduced in the denominator, and so that is how I knew something had to be wrong. So this is the limit as x approaches 4, reduce 1 over root 4 plus 2, which is 1/4. See that? They are the same. One requires that you do the whole definition of the derivative, and one is at a specific point. And then they want you to find the equation of the tangent line and the equation of the normal line, which I am confident you can do. Just so you know, the equation of the tangent is 1/4 x plus 1, and the equation of the normal is negative 4x plus 18. Tangent 1/4, opposite reciprocal, negative 4x. So plug in and you should get those same answers. In the next video, I'm going to be talking about finding the graph of a derivative from its function.